Hey guys, it's Houdini here, and this is going to be another contest coding tutorial vid using Java. And this time the problem is one of the more traditional problems you'll see in a contest, and this is the one that deals with currency. Essentially the problem is that you have a certain amount of cents or a certain price that you have to make up. And what you have to do is you have to figure out how many different ways using only pennies, nickels, dimes, quarters, and half dollars you can make this certain cost. Now there's a lot of other variations. Some of them won't work if they are like weird denominations where it's like 1, 3, 5, 7, 10, 12, stuff like that, where it's like crazy denominations that don't always add up together to make it like a greedy algorithm. So sometimes they have to use different ways to work around things and make stuff work. Sometimes they say what's the least amount of coins you can use to solve a certain change problem, and there's other things like that. But for today, it's just how many different ways can you make up a certain amount of money based on the pennies, nickels, dimes, quarters, and half dollars. And this one has a restriction where the price will be between 0 and 100 cents, so it makes it really, really easy. You start off, get your price, which you'll read in with your sin.next int. Just pick it up like that. Here's the input. It'll be like 62 as an example for the first one. And that's just the amount of money. So it's whole number, integer value that represents cents. Then what you need to get working on is you need to figure out how you're going to go through it. There's a lot of different algorithms you can use that will make it either easier or harder just depending on how you want to do it. I think the fastest one for this problem, at least the fastest to code, would just be a simple nesting some for loops. It looks really inefficient, probably because it is typically, but you can restrict it, and I'll show you a couple ways after I finish the basics of this to restrict it to make it not quite so inefficient. You'll see here I'm not using the braces to separate my for loops out because you don't really need to. You use braces when you need to have like longer blocks of code inside the for loop, but right here it's just nesting a bunch of for loops one on top of the other, and it makes it so that I don't really need to waste time typing in extra braces. You'll see here I am using the less than, not less than or equal to, because 2 half dollars would make up for a full dollar, but the restrictions that the input or the question gives me, which you can see in the description below, is 0 is less than the value of change, which they say is m, which is less than 100. So you don't need to worry about it ever being exactly 100. It's not less than or equal to, which is less than. So that's a little something that will help make it easier for coding, just less keystrokes basically, but you could easily do it by just adding 1 to the number that you're restricting it to, or just doing less than or equal to. So that's half dollar for HD, quarter for Q, dime for D, nickel equals 0, and you can have no more than 20 of those. And then also include pennies, which will be P. And what you can notice is that I'm just basically going to be trying every possible combination of the right amount of that would add up to possibly get it. And then my if statement here to check, I do HD times 50 plus Q times 25 plus D times 10 for 10 cents for a dime, nickels, and pennies. And if that is equal to the price, then I want to increment my count. Once I get through all those for loops, just out.println count, and that should be your answer. Let's see if I got it right. Looks good to me. 77, 39, 6, 187. That would match up for the input, which their whole input file, just get that up there real quick. 48, 17, and 87. This part up here, which I may or may not have covered in my last video, is basically just where you get the input actually has one more line up here that's 4, which represents how many times you're going to run it, which I store as a run count value right here. And using that for, that's how many times I run through the algorithm, which is 1, 2, 3, 4. And then I just do that. So that's all done up here with the sin.next line, gets rid of trailing white space, stuff like that. Sometimes you don't need sin.next line, but it's always okay to include it. It doesn't really affect the program very much. Then this looks like, oh look, what if he has to make it like the value is like $10,000 or something outrageously big that wouldn't ever really work out well, and you don't want to waste time in your for loop. You can add into here some tricks like HD times 50 has to also be less than or equal to the price. If you do it like that, then that restricts any time the half dollar by itself just blows up the loop. You don't have to you don't test that, and you just stop because you've already done. You're starting at 0, and you go to however many it takes before it blows up your loop and doesn't work. And you can basically just keep adding these all the way down, 50 plus the quarters times 25, like that, equals price, or it's less than or equal to price. And you just keep adding these down. I'll just do some quick copy and pasting right here. This will make your algorithm significantly more efficient at the larger denomination, just because you're making a lot more shortcuts and stuff to make it easier. Different problems have different ways you can optimize it, but for this one, this is definitely what I would recommend if you're concerned about runtime. As you saw there, I just ran the program and it was like almost instantaneous runtime, so you really don't need this for this problem, but I'm adding it just to be extra cautious in case they have some crazy judges data that throws everything out. And you don't need to include the extra and Boolean condition statement here to monitor it in the pennies, because all you have is one if statement here that will run, and we'll check and see if it is the price. You don't need to worry about if it's greater than or less than. You're checking is it the price. So you don't really need to add it there. It won't really affect it that much. And there you have it. That's a pretty simple problem, but it's very common to see this in a contest. You'll see this all the time where they want you to deal with change and you just need to write it out. So that's a condition where you're trying to see which is the how many times you can equal it. A little derivative of the question you can see here is lowest, where it wants you to have lowest cost or whatever of fewest, basically it's fewest coins when it says lowest cost, and you say if it equals price. You have to do a quick check right here, and then you say if lowest, what you'd have to do is you have to add up your P plus Q instead of, if you have it, so you have it like this. I guess I'll add it right here. This will make it easier. If I do HD plus Q plus D plus N plus P, so that's adding up all the coins, is less than my lowest cost, which you'll see there, like that. So that means that it's equal to the value and it is less than the lowest cost. I just set lowest cost equals HD plus Q plus D plus N plus P, like that. And that will give me the fewest amount of coins to get each denomination, which, oh, that didn't work out. What did I do wrong here? Oh, lowest cost. That should be better. Oh, no, it's not. What am I doing? Oh, didn't set lowest cost. Obviously, you want to make sure you set it to integer.max underscore value, all caps, because as you saw right there, I just made a mistake. I set it to 0, and what happens is 0 is always going to be greater than, or is it always going to be less than these, because you're adding up the coins that make the denomination, so it's never going to actually reset the value. You want to make sure you set, if you're trying to find the lowest number, you set it really big. You're trying to find the highest, you set it really low, like that. So then you have 6, 4, I'll make sure that adds up pretty well. 62, I guess that would be $0.50 plus a dime plus 2 pennies. Makes sense there. We'll try the 17 one, which is 4 here. I guess dime, nickel, and 2 pennies. Yep, looks good. So there you have it. That is using 2 different ways you can do it with however many possible ways you can have, or which is the lowest amount of coins to equal that denomination. Thanks for watching, and I'll put answers and everything in the description. You can just download them and see them. And yeah, I'll be back here with another tutorial on Monday.